Hello everyone, Dr. Polaris here. After covering the bizarre Therizinosaurs in the previous episode, I was in the mood for tackling other oddball dinosaur genera, and they certainly don't get much stranger than the subject of this video, the giant Godzilla duck mimic Deinocheirus. Native to the Maastrichtian-aged Nemegt Formation of Mongolia about 70 million years ago, this contemporary of Therizinosaurus was first described in 1970 on the basis of two enormous forelimbs, shoulder girdles, and a smattering of other isolated skeletal elements. Given the tantalisingly fragmentary nature of these remains, as well as the animal's gargantuan, almost 8-foot-long arms, Deinocheirus was very difficult to classify at first. I personally remember seeing a cast of this holotype at the Natural History Museum in London when I used to go there regularly as a kid. There was a small description plaque in front of the specimen that said something like, "In life, this animal must have been a pretty formidable predator." Given what we now know about Deinocheirus, this seems like a funny statement to make. Although when the exhibit was first opened in the early 1990s, this mysterious animal was still thought to have been a more quote-unquote typical carnivorous theropod. After decades of uncertainty, 3 new and thankfully far more substantial specimens of Deinocheirus were officially described in 2014, revealing a theropod that was far stranger than anyone could ever have imagined. Although a general consensus that this genus was probably an enormous Ornithomimosaur had been reached by the 2000s, Deinocheirus was substantially different from the most well-known members of this group, such as Gallimimus and Ornithomimus. Firstly, it was by far the most massive member of this group of Coelurosaurian theropods. The largest adult specimen of the genus, known formally as MPCD 100/127, measured an estimated 11 metres or 36 feet long, with the holotype representing a second smaller mature individual being about 10 metres long, while the third specimen was the smallest, being a subadult that had not yet finished growing. In addition, the animal's body was quite unlike that of other ornithomimosaurs, which are renowned for their often slender, ostrich-like builds. Deinocheirus had very long and narrow shoulder blades, connected to very pronounced and triangular shoulders. Somewhat surprisingly, given the enormous size of the forelimbs, Deinocheirus actually had proportionally smaller arms than the far more diminutive Ornithomimus. Unlike other members of the group, it didn't have pinched toe bones, so it certainly wasn't highly adapted for fast running. It also had very blunt and broad foot claws that were superficially similar to those of hadrosaurs, indicating a fairly slow-moving existence. While the forelimbs were prominent and well-muscled, being tipped with curved claws that were almost 8 inches long, the hind limbs were comparatively short and stocky, being adapted for bearing the animal's significant weight, which has been theorised to be about 6.5 metric tons. This makes the genus among the largest and heaviest non-avian theropods. While it was certainly a heavy-set genus, the ribcage was relatively tall and straight, suggesting that its body was quite narrow. The neural spines of the 12 back vertebrae became increasingly longer from front to back, and were supported by a system of interconnecting ligaments, which stiffened the vertebral column, allowing it to support the abdomen while transmitting the stress to the hips and hind limbs. The long spines on the animal's back indicate that Deinocheirus had a prominent sail or hump, which may have been utilised for display, thermoregulation, or as a source of fat storage. The sail then diminished before the start of the tail, which was relatively thin and elongated. It had extremely lightweight pneumatised bones, which was shot through with respiratory air sacs, helping this animal to save on weight. Interestingly, the tail ended in fused vertebrae, like those seen in Therizinosaurs, oviraptorosaurs and birds, indicating that it had a pygostyle and thus a fan of tail feathers. Feather impressions are known from other Ornithomimosaurs, although it's currently uncertain exactly how much pelage Deinocheirus would have possessed. Given its massive size, the genus may have been quite sparsely feathered, with the exception of the back, forelimbs and tail tip. As if all this weirdness wasn't enough, Deinocheirus had a pretty strange cranium as well. Only a single well-preserved skull is known, which belonged to the largest adult specimen. Measuring just over 1 metre or 3 feet 3 inches long, it was slender and narrow, traits that the genus shared with other Ornithomimosaurs, although its snout was notably more elongated, with the lower jaw being substantially deeper and more robust than the upper. The jaws were toothless and terminated in a spatulate beak that was superficially similar to those of modern ducks, indicating a broadly herbivorous diet. The animal's bite force was weak for its size, suggesting that it fed on relatively soft vegetation, perhaps while wading in rivers and lakes. In addition, the deep lower jaw probably supported a long muscular tongue, which could have assisted the animal in hoovering up food material obtained with the broad beak when foraging on the bottom of freshwater bodies. Over 1,000 gastroliths were found in the stomach region of the specimen MPC D100/127, alongside the vertebrae and scales of river-dwelling fish, suggesting that Deinocheirus may have been an unfussy omnivore similar to modern mallard ducks. The massive forelimbs and curved claws may then have been utilised for uprooting aquatic vegetation, pulling it closer to the animal's mouth. CT scans have revealed that this genus possessed a relatively small brain for a non-avian theropod, being within the established range for sauropods instead. This is in contrast to other ornithomimosaurs, which have comparatively large brains mostly devoted to coordination and balance, indicating that these traits were far less important for the enormous Deinocheirus, which would have relied on its sheer size as a defense against predators. Fully grown adults would have had to worry about just a single predatory theropod, with this being the large tyrannosaurid Tarbosaurus, which was the top-order carnivore of the Nemegt Formation. Indeed, we do have direct evidence that Tarbosaurus at least fed on Deinocheirus, with bite marks being present on the gastralia of one specimen. The environment in which these big theropods lived is sometimes represented as being a harsh Sahara-like desert, as seen in Prehistoric Planet for instance. However, all the information that I could find concerning the ecology of the Nemegt Formation indicates that the region consisted of a vast alluvial plain crisscrossed by large rivers and lakes, in addition to drier areas housing forests of Araucaria conifers, bald cypresses, plane trees, hornbeam and ginkgos. Various freshwater plants were present in and around the marshes and swamps, the majority of which would have been on the menu for Deinocheirus, such as lotuses, duckweed and reed grasses. The climate of this environment was probably cold continental and at times semi-arid, being affected by the Asian monsoon system, producing warm wet summers and cool dry winters. While the ecosystem here was roughly comparable to the modern Okavango Delta in Botswana, and was clearly capable of supporting a diverse array of large herbivores, including titanosaurs, hadrosaurs, ankylosaurs and Therizinosaurus. Annual average temperatures were low for the Mesozoic, being estimated to have been around 7.6 degrees Celsius or 45.7 degrees Fahrenheit. Other animals present here included a variety of turtles, the crocodilomorph paralligator, alverosaurs such as the egg-stealing Manipulonyx, at least 9 species of Oviraptorosaur, and several other ornithomimosaurs that were distantly related to Deinocheirus, such as Anseriamimus and the famous Gallimimus. Speaking of relationships, Deinocheirus was the type genus for the family Deinocheiridae, a group of ornithomimosaurs that were not well adapted for fast running. Exactly how many genera are placed in this family varies from study to study, with most finding the group to include Deinocheirus, Garudimimus, and Paraxenisaurus. The latter is a highly fragmentary animal known from the Campanian-aged Mexican Cerro del Pueblo formation, and as such little can be said about it apart from the fact that it was pretty large, potentially reaching 5.7 metres or 19 feet long and weighing 600 kilograms or 1,300 pounds. While this is tiny in comparison to the gargantuan Deinocheirus, this would still make the genus among the most massive ornithomimosaurs. Meanwhile, the older and better known Garudimimus was also native to Mongolia between 96 and 89 million years ago. It was a far smaller animal than both Deinocheirus and Paraxenisaurus, being about 3.5 metres long and weighing as much as an adult human. However, like Deinocheirus, Garudimimus possessed relatively stocky hind limbs, as well as robust feet and a broad pelvic girdle, with the animal clearly not being adapted for fast running. How modestly sized ornithomimosaurs like this developed into enormous forms such as Deinocheirus is not well understood, although given that this family was not adapted for speed, it made sense to invest in size and bulk instead. with the bizarre duck-like foraging habits of the type genus possibly emerging as a means to avoid competition with other large herbivores, such as hadrosaurs and the contemporary Therizinosaurus. Hopefully more members of Deinocheiridae will be uncovered in the future to help give us a better idea of just how this bizarre hunchbacked Godzilla duck theropod evolved. Thanks for watching everyone. Before I go, I'd like to make a quick apology to my patrons, as I haven't properly thanked you guys and gals for your unerring support of my channel. Your contributions really mean so much to me, and I've been so distracted lately trying to finally get my PhD finished that I forgot to give you all the proper thanks. You'll be glad to know that I handed in my thesis just before Christmas, so I've now thankfully got a bit more room to breathe. The next episode will be covering another strange group of theropod dinosaurs, in this case being the termite and/or egg-stealing alverosaurs. See you again soon. Cheerio.